Rock descriptions are made on samples recovered from boreholes and excavations and/or from examination of the in-situ materials. The characteristics of a rock which play a major role in determining its engineering properties and need to be given due attention when describing the rock are the strength, weathering effects, and the discontinuities. The discontinuities are the most significant of these, and so particular attention is paid to this aspect. Engineering properties of rock are not included in and cannot be reliably inferred solely from this type of geological classifications, although a particular rock name can often indicate a range of typical engineering characteristics. Geological classification of a raw material is necessary to appreciate the geological origins and structure of a rock of an area, to establish geological correlation between boreholes and to distinguish boulders from bedrock. This knowledge is also of importance when rock material is required for construction purposes.
Hi, I'm Muhammad Aznizan Amri. The apparatus needed for the core logging experiment are the core sample and the measuring tape. In this experiment, two core samples need to be prepared, and the core sample is measured using the measuring tape. As you can see, there are fractures on the samples, so the fractures need to be identified first. For the fractures, the core covered is measured from center line to the center line. Next, the core length is measured. For an example, for the first fractures, the length is 90 mm. So the first data is 90 mm. And all of the core length need to be recorded and tabulated in the table. So the steps needs to be repeated on all core. The core recovery CR is calculated using the formula. For this experiment, the rock quality designation is calculated by using only solid core more than 100 mm. The rock cores.
Okay, so now we move on to the results and calculation. Alright, so for core recovery is the ratio of core recovered, solid and non-intact to the length of the core run. So for the formula of the core recovery, which is in percentage, is the length of the core recovered divided by the length of the core run. We times it by 100% to get the value of the core recovery in percentage. Meanwhile, for rock quality designation, which is also known as RQD, is the ratio of solid core pieces longer than 100 mm to the length of core run. So for the formula of RQD, which is in percentage, the core length more or equal to 100 mm divided by the length of the core run times by 100%. Okay, so this is for sample calculation. We take core A as example. So for core recovery, which is in percentage, we just add the value of the measurement from center to center, which as I mentioned just now from the previous slide, we take all the value including solid and non-intact. So we just add all the value, which is 90, 200 and so on. We just add it and then we divide it by 1500 and we times it by 100%, so we get the value of 100% here. So for the rock quality designation, as I mentioned just now, we only take the value of n equal to 100 mm from center to center. So we just take 200, 100, 150 and so on. We divide it by 1500 and we times it by 100%, we get the value of 61.33%. Okay, so now we move on to the results. So for core sample A, we obtain the result of core recovery 100% and the rock quality designation of 61.33%. So from the value of the RQD itself, we can see that the core sample A is moderately weathered rocks and it has severe weathering along the joints. Meanwhile, for the core sample B, we obtain the value of core recovery 100% and the RQD value of 79.23%. So from this value, we see that core sample B is a hard rock and it has weathered along the natural joints. Lastly, we move on to the rock mass quality. So for core sample A, as I mentioned just now, we obtain the RQD value of 61.33%, which by referring to the rock mass quality index, we obtain the fair rock mass quality. For core sample B, we obtain the value of 79.33% of RQD, so the rock mass quality is good.
So hi, my name is Su Yang and I'm going to present about the discussion part. So two core samples we're using here, which are the core A and core B. Calculations are done to carry out the value of core recovery and rock quality designation, which are abbreviated CR and RQD respectively. So let's start with core A first. The CR value of it is 100% and RQD value of it is 61.33%. Based on the RQD value of core A, we can say that it has only fair quality and specifically a moderate weathered rock quality and just around 10% away from the poor quality of rocks. And now we can look at core B, which has CR value of 100% too and RQD value of 79.33%, almost 20% better than the quality of core A. So we consider it as a good quality rock, or we can just call it hard rock. So based on the illustration of these two samples, obviously core A has much more broken pieces compared to core B, and we can say that the more shattered parts, the higher the weather rate of the rock samples. And we can actually observe the weathered along the joints of the core. Core A is obviously much more severe weathered than core B. And that's all from me. I'll pass it to my next team member. Thank you.
From the results, we have obtained the core recovery and rock quality designation value. Also, we have obtained the physical description of the sample. Therefore, we have achieved the aim of the experiment. So to be concluded, the rock mass quality obtained for core A and core B is fair and good.